Hello to everybody and welcome to this tutorial. Today I would like to show you how to simulate contact interference between a shaft and a bearing. So I would like to show you how the overclosure between the shaft and the hole of the bearing can increase the stress on both components. So in this case we are going to simulate this green bearing with this blue hollow shaft. So our example will be overclosure. That means the radius of the shaft will be higher than the radius of the hole. In this case, 50 microns overclosure. So to do so, we are going to set a model with Hypermesh and send it to process with Abaqus. Also, we are going to use 1/4 of the model thanks to the symmetry. Material will be steel for both components, and the target will be the pressure fit induced stress. So the units I'm going to use will be newtons, millimeters, tons, and seconds. So yes, 50 microns overclosure. So yeah, let's start now. The first part of the problem will be developed with Hypermesh and we'll send to process it with Abaqus. So first of all, open Hypermesh, make sure you have the Abaqus profile. So we need to import the cut. So sorry. To open it, both of them, cut part. Done it with CATIA. So okay, we have both components. Go to model, we can change the color. Okay, and the first thing we need to do is just create few nodes to ease the partition in 1/4 of the model. So if we go to geometry, nodes, 0, 0, 0, yeah, this will be the center of the axis of the shaft. E50, create this one. Create, here I created thanks to this line, create. Okay, good. So next thing I'm gonna do is just cut with solid edit, trim with plane surface, select both solids, and select the nodes. Trim, select again. Trim. Okay, so we have 4 parts, so we need to delete what we don't need it. So if we press F2, we have the delete option. We need to select solids. Okay, so we don't want these ones, so delete. Oh, sorry. Ctrl Z, delete bounding surfaces. Okay, now, great. So another thing we need to do is just, as there is symmetry with the bearing, I would like to partition it into halves, doing the same thing. But now I need to create different nodes. Just clicking these points. I need 3, so these 2 will be enough with this one. Okay, so again, solid edit, select the bearing and the necessary nodes. So trim, and again F2, select the solid and delete. Okay, so next I would like to mesh this face and this face with 2D elements, quads in this case, and I would like to propagate the mesh creating 3D elements. So first of all, I would like to create another supporting node by clicking this and this. Okay, and if we press F2, or if we go to the auto mesh, we can select all the surfaces. So if we go, make sure you have selected make current, well, I don't see that, but here, make current, the original component. In this case, this bearing is selected, is the current component, so all the mesh we are going to create will be created in this one. So select this face, size of 3 millimeters, and select quads elements. Yeah, everything looks fine. Okay, this is the mesh. We can edit a little bit. We can increase the number of elements. Okay. So I prefer, yeah, like this. Looks fine. Okay. So, and now we can make current the hollow shaft. Sorry, and mesh this face. So we can modify a little bit the mesh to make it nicer. Yeah, looks good to me. So mesh. Okay, so what we need to do later on is just go to go to 3D, spin. Let's try to mesh the 3D bearing. So we spin elements, we select my face, the axis will be the x-axis, spin axis. So this base B, this node, angle 90 degrees, spin 50, and bias intensity 1. You can see how I didn't select the bearing, so we can return, Control Z, make the bearing current, go to spin, select the faces, again the same thing, 2 will be fine. Okay, we can edit a little bit the mesh by increasing or decreasing the on spin. So it looks fine to me. So we are going to reflect all these created nodes by going to Tool, Reflect, and selecting the elements created by attached, and we are going to select 3 nodes of the plane. We are going to reflect these nodes. and then duplicate the elements to the original component, reflect. Okay, although looks fine to me, but these two halves are not joined. That is, there are two nodes very close, but they are not joined. So we need to go to Tool, Edges, select the component, and clicking Preview Equivalence. These dots, these points, means that there are two nodes very close, closer than 0.01, which are not coincident. So we need to click in equivalence, and now we have only one continuous part. So the bearing is okay, is finished. So we need to go to 3D, go to whole shaft, make current, go to 3D, drag, select drag elements, select the face of the shaft, and say that I want to drag from this point to this one. So we change the distance from N2 to N1, on drag 50, bias intensity 1, drag. Okay, so 3D mesh is done. So I would like to go to press F2 and select the faces created before. No, this one. My face, delete. This one looks, it's already deleted. Yeah, okay. So I would like to go now to element types and check the element types. We go 3D20, here 20R. So I will change it to this one. Select everything and update. So everything now is second order. The order change, we can do it this way. Now we've got second order elements, but we can change it to first or second using this tool. So what I'm going to do next is create a material. Material is going to be steel with elastic properties, Young modulus Poisson's ratio. We can put density, although it's not needed. We can add it. Okay. So now I need to create property steel property. Okay, will be solid section. Yes, with material steel. Okay, we need to go to apply the property, steel property, bearing steel property. Okay, so I'm going to hide the CAD. Okay, and what I'm going to do next is to create the contact surfaces between the bearing and the shaft. One thing I didn't mention is the CAD internal radius. The internal radius of the bearing and the external radius of the shaft are the same in the CAD. As we meshed the components, the radius is not going to be coincident. So it's not a problem because we adjusted we will adjust it with contact pair definition. So, well, let's go to Tools, Contact Manager. Let's create surface, bearing surface. Okay, which select faces. Okay, close. And now the shaft. Select the elements I attached, faces, right click, drag and remove all these elements. So we are going to add all these elements, close. And now we need to create a surface interaction. New interaction. Going to click on surface behavior and friction. Go to surface behavior with penalty 0.1. Go to friction, coefficient 0.15. Okay. Yeah. Okay. So quickly we go to interface and create a contact pair. Contact pair will be bearing shaft. Contact pair. Create the slave is gonna be the bearing, and the master will be the shaft. The interaction will be interaction. With adjust, we are going to make both radius, external radius of the shaft and the internal radius of the bearing the same. It's going to be projected to be the same, so 0.05 should be fine. And clicking small sliding. Yep. We can also select surface to surface. Apply, okay. Okay, so we quickly go to create cyclic surfaces. This will help us to define the cyclic symmetry, cyclic 1. Okay, elements. So now I need both components. Attached, proceed, faces by face. Okay, this is the first one. And the second one, cyclic 2. Same, select both components, faces by face, proceed, add. So an important thing is to check the normals. Both surface elements are pointing to the same direction. So this is good, yeah. So we need to create a tie contact with both surfaces. So tie contact, it's going to be tie. So it doesn't matter which one is slave or master. Okay, we go to parameter, cyclic symmetry, type surface to surface. Okay, so all the contacts are created. So now what I need is to create an endset called boundary condition. I'm going to select all the nodes which are going to be constrained. So if I go to here, proceed. Okay, so for one node, okay. So what I'm going to do now is quickly export it to Abaqus. So Abaqus files, press fit. IMP is the file. Okay, I'm gonna export everything. Export. Although we have created a contact pair and a tie contact, the symmetry and the clearance are not yet defined. So I'm gonna do the definition of this by opening the file we have exported to Abaqus file. So we quickly open the file. Okay, you can edit it with Notepad. You can open it with Notepad++. I like to use that one. Although you can use whatever you like. So we quickly go to the end. Okay. And the way I'm gonna define clearances and the cyclic symmetry is just pasting text on this file. So if we go to the end of the file, okay, at the end I'm going to add some text. So paste from another file. So I need to change, this is clearance, just added this line. I'm gonna change the ball surface. It's gonna be shaft. This is the surface we have defined before. The bearing surface will be bearing. Okay, the slave is the bearing, the master is the shaft. And here I have the overclosure value will be 50 microns, so it should be negative. If it would be clearance, it will be positive. So yeah, I'm going to add the cyclic symmetry. So just paste cyclic symmetry. These three, yeah, 4, because we are using 1/4 of the cut. So these 3 zeros means the coordinates of a first point, and these 3 points means the second coordinates of a second point. These 2 points define the line, a line, which is the center axis of rotation of this shaft. So in this case would be this and this, following the x-axis. So what we need to do is just change. This is x, y, z, x, y, z. So we need to select another point in the x-axis. Okay. So next thing I'm going to do is just paste the step here, just here. I added just step with non-linear geometry consideration, static step with first iteration of 0.1 to 1 seconds. Boundary conditions will be the endset I created before, boundary condition with XYZ displacements constrained, okay? And this is very important. Contact interference shrink. This is going to simulate the overclosure. So what I need to do is first the slave, define the first slave surface, and second the master's surface. So again, slave will be bearing, and the master will be the shaft. Okay, and this output, all these outputs. Yep. So we can save and quickly go to Abaqus. So this is Abaqus, which set the work directory. This is the one I want, so I won't change it. So I'm going to import the input file I have generated from model. So change it, okay. And quickly I'm going to send it to analysis. So go to job, create, from input file, press fit, continue, okay, and submit. So this will take a few minutes, so come back later. Okay, so the model is completed, has run. So we go to results. Okay, we can remove from here only the elements and show feature element edges. So yeah, this is the von Mises stress. So what I would like to do is just show the hoop stress. To get the hoop stress, we need to change the coordinate system. So we need to create one system following 3 nodes, cylindrical. Okay, so we select this one, and this one. Okay, now I have a new system of coordinates. So what I need now is go to results, options, transformation, user specified, system of coordinates 1, this is the one we have created. So okay, so yes, this is S22 is gonna be now the new hoop stress. Okay, we go to S11, this is the radial stress, and Z stress, the axis. Okay, so this is a good example. So one thing we can do as well is just mirror X, Y, and ZX. Okay, as we did 1/4 of the model, we can mirror it and see the whole model, although looks like it's better see 1/2. See the patterns, stress patterns. Okay, so this is a good example. This is also, you can check the results with analytical formulas. So yeah, thank you very much for watching this video, and don't forget to subscribe and like us. Okay, so thank you very much. Bye bye.